Hello everyone, hope that you are revising for WA1s. Right, the reason why I want to do this video is because I realize a lot of you do not know how to do the perfect square and perfect cube question, which is why I'm going to explain it really quickly right now. Okay, so when they ask you to find the smallest integer k such that p times k is a perfect square, what does this mean? So given that p equals to 2 times 3 cubed times 5, what you realize is that if I were to try and distribute p into a square, meaning that I have 1 copy of 2, 3 copies of 3, and 1 copy of 5, right? Then I will have 2 on one side, and then not enough 2 to go on the other side of the square. I have 3, and then another 3 on that side. Okay, but then I have 1 more 3, I have 3 3s, and then 1 5. Okay, but what you realize is that the distribution is not very even for the numbers. So if let's say I want to make p times something, so I want to multiply something to p such that it can create a perfect square, what do I need to multiply? So if you can see, after I distributed everything, you realize that I actually need another 2 on one side, another 3, as well as another 5. Okay, so that is what I need to make a perfect square, because a square has 2 equal sides. Am I right? And how did I distribute the blue color numbers is from what p has, but then the green color numbers are what p needs to become a square. Okay, so in the end, when we think about k, which is multiplied to p to make it a square, k would be equal to the green numbers 2 times 3 times 5, which is what I need to make p a perfect square, and that would in total be 30. Okay, so the answer would be 30. Okay, now what if I want to make p a perfect cube, right, instead of a perfect square? So let's think about a cube. A cube instead of a square has 3 sides, right? 3 sides, and all 3 sides of a cube must be equal. Okay, so now let's try and make use of what we learned from the squares and then use it for the cube. Okay, so if p equals to 2 times 3 cubed times 5, that is what I'm working with. 1 copy of 2, 3 copies of 3, and then 1 copy of 5, right? You realize I can put the 2 here, right? But then no more. I can put the 3 here, another 3 here, and maybe a 3 at the bottom, right? Because I have 3 sides that I'm looking at, correct? Okay, and then that's it. I have a 5 here, and then you will realize, oh no, you see, I don't have anything more, but I need to have 3 equal sides. So what do? I need to multiply n to p to make it a perfect cube, right? So I will need to multiply 2 to this side, 2 to that side as well, because it's missing a 2, and then 5 to this side and 5 to this side as well. Okay, in total, I will need 2 extra copies of 2 multiplied by 2 extra copies of 5, which makes n equals to 2 squared times 5 squared. Okay, this will give me 100. Right, and 100 is what I need to multiply to p such that I can make a perfect cube. Okay, so I hope that you understand this concept, and all the best for WA1s.